Okay, mic is on. All right. We're going to grab this dude. This dude has 3 different transformations going on. So step 1, we're just going to actually use our knowledge from Friday. We're going to pick off these 4 properties. These 4 properties, you can just get right from the equation. We just write them down. Axis, staring us in the face, y equals -3. Let's jot these things down. Y equals -3. Is there a phase shift? Yes. We're doing x minus 30 inside of our sign. And a minus means we go right 30 degrees. Is the period changing? Let me ask you guys. Is the period changing here? We multiplying x by anything? No. The period there, therefore, is still just 360 degrees. Our amplitude, we look at the number in front, is 2. We have all those properties from our work from Friday. So how do we sketch it? So this algorithm will never fail you. Well, unless there's some user error, but it's not my fault. The algorithm is good. I kid. Let's go. Number 1, everybody draw the axis in with a dashed line. It will help you. Now, I'm not going to use my straight line tool. If you have a little ruler or a straight edge with you, that's good. Or just freehand it like me. Just draw the axis in. It's going to be really helpful because now you can almost visualize, okay, from there, I'm going to be going 2 above and 2 below. You can kind of visualize the boundaries of your sine function. So that said, as an optional thing to do, not everybody likes this because it can maybe make your graph a little more clunky. But if the amplitude is 2, draw some more dashed lines for how high you're going to go and how low. Yes, Griffin.
How is it not like down the axis?
Is it down? Yeah. Why did it take so long for you guys to point that out? It's -3, and I wrote 3, and then I drew 2. So it's just like a comedy of errors here. I stayed up late last night. I apologize. And then I got up early to swim. Bad combination. So erase, delete, like Matt Hardy. Delete, delete, delete. Anybody get that reference? Okay. Thanks, Kervin. Glad you pointed that out. We're going to leave that in the YouTube video because we all make mistakes. The axis is -3. We draw the axis at -3. If you already drew it at 3, my apologies. All right, so now second optional step. I'm going to do it though. I'm going to draw using the amplitude. I know I'm going to go 2 above and I'm going to go 2 below. I'm using a different colored pen. If you're just using a pencil, maybe do it in bold. If you did the axis and dash lines, I'm not your dad, do what you want. See, we can visualize our graph to be bound between that max and min, centered around that midline, that axis. All right, next step here. This is kind of critical. We have to use our knowledge of the sine function. So we learned on Friday, and you guys already know from the previous week's work, that the sine of 0 is 0. Would you guys agree the basic sine function, it starts at 0, 0. And no matter which course you're in, that has to be burned into your minds. The sine function starts at 0, 0. So for our sketch, what we're drawing here, instead of starting at 0, 0, we have moved everything down 3 units. So we would start at 0 minus 3, except we've also shifted everything to the right by 30 degrees. So instead of starting at 0, 0, that point has been shifted down 3 and right 30. So I'm going to, on my graph here, on my axis at 30 degrees, I'm going to put a big dot here that I'm going to label SP for starting point. That's the key for the whole sketch. And then since I have some space here, maybe I'll write this. 0, 0 went to 30 because it moved right 30, and then -3. So that's where our graph's going to start. All right, next. We know our sine function goes up, comes back down to the axis, goes down, and comes back up. So in one full period, it actually comes back to the axis halfway through that period. So on our graph here, every half period, let's just add more points. So if our period's 360, that means every 180, we're going to add a point on our axis. So you guys can do that just by counting squares. Every tick is 30 degrees here. So that means 6 squares, you make another tick. And then in another 6 squares, you make another tick. And you can start visualizing your graph going up and coming back down. And I'm just going to fill up as much as I can on my graph. I'm going to come back to the axis at all these other points. And then because we did this dashed line with our highest values and our lowest values, and we're going to start here, now we can use the amplitude to plot our maximum and minimum points. So I might just slip to a different color, maybe bright red here. So from our starting point, the sine function goes up. Halfway between when it's going to touch the axis, we have a maximum. And then halfway between the next points on the axis, we're going to have a minimum. And then we don't make a lightning bolt or a Pikachu tail. We just do a nice curvy. That's a pretty nice one. I'll give that a level 4. That's one cycle of our sine function. Now, I'm going to fill the rest of my graph up as much as I can. Minimum, maximum. That looks pretty nice. 2 cycles fit perfectly. And of course, we keep going forever left, forever right. This is the algorithm. Get our properties, draw the axis, max and mins, find the starting points, use the period, and then find your max and mins and plot them. You're going to get into a good rhythm for today, and that's our goal for today, guys, is just to make as many sketches as possible. Let's apply the algorithm to this one. So scale is the same. And 95% of the graphs I have you guys make, I'll provide the grid for you, and I always stick to that 95% of the time. I'll stick to 30 degrees. You can always just have that every 30 degrees is one tick. It's the same thing here. So our axis, let's pick it off. Our axis, -2. All these things are readily available to us. Y equals -2. Is there a phase shift? Are we subtracting or adding anything off the x inside sine? The answer is no. So you guys can write none or NA or put an x through there. Do what you want there. Period. We're multiplying x by a number. The period will change here, and the period is going to be 360 divided by 2. So far, I think this is we've only sketched periods of 180. And then the amplitude is not -2. The amplitude is going to be 2, but if you'd like to put in brackets that it'll be flipped, you can do that. So everybody in the room should be able just to pick off those properties. We don't have to think too hard. They're right there for us. All right, let's use the algorithm. Sketch the axis. I'll draw it right this time at -2, dashed line. And then use the amplitude. I'm going to do this, I think, for at least the first few. The amplitude is 2, so we're going to go 2 below that, and we're going to go 2 above that. Thirdly, where is our sine function going to start? There's no phase shift here. So our starting point will just be where it normally is on the axis, centered at 0, 0. I'm going to keep labeling that with a little SP for starting point. And if you'd like, you can label how we got there. The axis is -2. We just shifted down. All right, we need a squishier function, but we don't have to eyeball it. The period's 180. That means every 90, half a period, you're going to come back to the axis. So every 90, put another dot. Put a dot here, put a dot here, here, and here. And we're almost done. We're going to go up to the max line, down to the min line, but be careful. This function was -2 sine, which means from our starting point, normally we go up. This one is flipped. So halfway between our first two dots, we'll go down to a minimum, up to a maximum. There we go. Nice one full cycle. I'm going to draw a second cycle in here. 2 in the books. It's the same process every time. And, if you just try to follow the algorithm, you guys, let's say you're on a test, you guys write down all the properties for me. You draw on your axis, you draw a dashed line for the max and min, label your starting point. If you make a tiny mistake here or there, I can still give you most of the marks. 2 in the books. Anything you guys want to chat about? Maybe you guys can try this next one a little bit more independently. Oh boy. All four transformations going on here. Something for everybody. You guys go. Get the properties, draw on your axis, use the algorithm. I'm going to force myself to wait a couple of minutes. All right, I'm going to play catch up with the properties. Contain your excitement, guys. We're going to sketch one with a period of 720 this time. Brand new. It's going to take up one cycle. We'll take up our entire graph. Absolutely. I can't resist. I'm coming along for the ride here. Draw the axis. 3 above, 3 below. Count the squares. We're going to go up to 2. We're going to go down to -4. Find your starting point. We're shifting left 90 here, so we're going to start. I've been using black. We're going to start here on the axis, but left 90. And then we just got to plot more points. The period is 720. That means half the period is 360. So the next time we touch the axis will be at 270. And then we're kind of off the grid to the left, aren't we, a little bit? That's fine. Let's just sketch what we can sketch. So the sine function starts going up. Halfway between -90 and 270, we'll hit the max. You can think of it this way too, every quarter period. So this would be 180 degrees at the max. And then go back the other way. Go back 6 squares, go back 180, we'll have a min. And that's really the only points we can fit on this graph. This one wasn't squished. This one was stretched out a bit. So you guys, that's kind of the best we can do with the grid we've been given. We can do it, guys. Use the algorithm. All right, I'm going to let you guys do D independently. And then we'll do that second type of question together. We'll make an equation together. Just give it a go. Don't be like, sure, just actually try. Oh, sorry, Asher, if you're watching this.
I was just thinking of it. I told
They get the 3Ms to practice so that they can tune me out when we start graphing some functions. I mean, if they haven't already tuned me out, they can tune me out. Guys, I'm personally very excited. We've switched our sine function by a factor of 3. The period is going to be 120, brand new period to sketch. Let's make a sketch. Amplitude is 3, so we're going to go up to 1. And we're going to go down to -5. And our phase shift is left 60 degrees. So we're going to start here. And then the rest is just plotting some points. So the period is 120. That means every 60, you're going to come back to the axis using our algorithm. 60 is 2 squares horizontally. And then from your starting point, there's no flip here. It's just up, down, down, up. So up to a maximum, down to the axis, down to a minimum. There's one cycle of this function. Very nice. I'll plot more cycles. I'll plot those in a second. I have suggested when you guys are practicing, most of you guys can get Desmos up on your phone pretty quick. If you bring up Desmos and change the settings to what we used last week, you can pretty easily check these answers because your grids will look like Desmos pretty much. Let's finish this off. All right, and you guys aren't making lightning bolts. You guys are making nice smooth curves. Something like that. Okay, so the last exercise that we'll do with everybody, so the 3Ms can join us too. Let's actually, instead of having an equation and making a graph, let's take some information and work backwards and find a graph. So we've got a bunch of blanks to fill in here. Note we are assuming no phase shift, so we have to be able to fill in the A value, the K value, and the C value. I'm going to wait a minute. I think you guys could figure out each one of those without showing any work, but I'll show you guys how to find those in a second. What do you think? Fill in the 3 blanks. We might be told some of those things. We might have to work for some of those things. Time is flying. You guys have done great today. What do you guys think? First blank. Maybe somebody hasn't helped out yet today? Jordan. 0.5 because the A is basically our amplitude, right? Absolutely. Can I spell amplitude? Which is just 0.5. We can plot it in there. First blank. Second blank. What are we multiplying x by? We actually had an example like this earlier. So if you guys flip back, anybody figure out what we're multiplying x by? Sam? 0.5. How'd you get 0.5?
Because 360 divided by 0.57.
Exactly. If you want to set this up like the following, you could ask, okay, 360 divided by what number gives us our period of 720? And that gives the following. You can get k by doing 360 divided by 720. You could, what am I trying to say? You can do those with mental math or just with the division. But yes, k is 0.5. You also might have just looked back in the lesson and saw that it was 0.5 gave us the period of 720. That's the second blank. We got to work a little bit for the third blank, the axis. But the one piece of information we haven't used yet is that the maximum value, the max y value, is equal to 1.5. Now guys, if you know the maximum and you know the amplitude, then you know where the axis is. To get the axis, we're going to take our max and we're going to subtract the amplitude, which you guys can just do with mental math, just 1.5 minus 0.5. So the axis is actually just equal to 1. We've got a little plus 1 on the end here. If we were to go back and graph that function, it would satisfy all the properties that we just talked about. So a good little exercise. All right, 3M people, that's what you guys need to be able to do. Graph some sine functions or take some information and make a sine function. If you want to follow along, graphing the cosine function is you guys can do it. Like, it's just not part of the 3M curriculum. I just don't want to get in trouble by forcing you to do it. So follow along, it's optional, but the 3 U's, we have to be able to graph cosine functions. And we're going to see there's only one change, yes? Yep. We're going to see there's only one difference. The 4 properties for this graph, same idea, we can pick them off very quickly. Axis is y equals 1. No phase shift here because we're not subtracting anything off x. Period is still 360 here. We're not multiplying x by anything. And the amplitude is 2. So if you guys notice, for graphing the cosine function and the sine function are identical in every way except where they start. The sine function starts at 0, 0, whereas the cosine function starts with the maximum at 0, 1. Everything else is the same way. So when we're applying our algorithm, let's actually start using our algorithm. We'll sketch the axis in. Y equals 1. And I know it's optional. I like doing it, though. I'm going to keep doing it. The amplitude is 2, so I'll go 2 above and 2 below. 2 below. All right, but things change up a little bit. We're not graphing a sine function, we're graphing a cosine function. So normally we start at 0, 1. However, in this case, our axis has shifted up and our maximum is kind of shifted up to 3. We start at a maximum, we're going to start at 0, 3. We start at a max. So you guys can think cosine starts with the maximum. I'll say this. Cosine starts at a maximum. So for us, that there's no phase shift, so we'll just start at 0, 3, and I'm going to label this one with a starting point. Once you have one point, you can graph the entire rest of the function. With cosine, we got our starting point. Things are a bit different though. This is not on the axis, but what we can do is If you guys know the period's 360 and there's a maximum here at 0, then in another 360, you're at the next maximum, right? So let's do another maximum 360 down the road. We're just using the fact that it's periodic. I'll go back the other way too. And then for me, the easiest way for me to continue is to recognize, okay, well, halfway between my maximums with the cosine function, I have a minimum. So I'll do my minimums next. Halfway between these is at 180 and then down there. And it'll do that again. Honestly, this would be a fine sketch with the max and min, but we can add a bit more detail. Halfway between your min and your max and your min, you come back to the axis again. So that's 6 squares, and 3 squares will be back to the axis. So we can just add more points. And we have a nice sketch of this cosine function. So properties all stay the same. It's the way we find them stays the same. Draw the axis, draw the max and min values, but then our starting point changes. And that's where things get a bit different. You guys can do it though. Once you find one max, you know where all the other maxes are, then you can find the mins, and then you can find points on the axis. Can you guys try this next one? I haven't changed the period for this one yet. I'm going to give you guys a head start, and then maybe we'll do C together. C has everything. All right, I'm going to come along for the ride here. Axis y equals 1. Phase shift right 90. Period. Nothing changing for this one either. Amplitude 3. Draw the axis. Draw the max and min. Draw the max and min. 3 below. And you just need 1 point to unlock all the rest. Normally, we start at a max. This time, we've shifted over an extra 90 degrees. So we will start here with a max at 90 because it's a cosine function. Then everything else is the same. So we'll get another max at negative 270. Halfway between those, you're at a min. Halfway between max and min, you're back at the axis again. And you have nice one full cycle. And then you can just continue the pattern. Up, down, up, down, up, down. This isn't a formal thing, but you can think of it like every quarter period, which in this case was 90 degrees, you're going from a max to a min, or sorry, from a max to the axis, or from the axis to a min. Every quarter period. All right. Let's try one more. I think I'd like to wrap things up, so I'm going to do this one with you guys. We've got everything here, including a flip. This is the most complicated I could make graphing a function for you guys, but we can do it. Let's get our properties. Axis y equals 1. Shift left 90 degrees. Period has changed as well. It's squished from 360 to whatever 360 divided by 2 is. In our amplitude is not negative 4. Our amplitude is 4, but the negative means we're flipped. Is it just me, or has the axis been 1 like 4 times in a row? It's not just me. Those were all 1. That one was -2. Okay, just all these ones are 1. Draw the axis, draw the max and mins. 4 above, 4 below. Where do we start? So cosine usually starts at a max. So if this was 4 cosine 2x plus 90, I would go left 90 and start at a max. But it's flipped. So instead of going left 90 and starting at a max, we're going to go left 90 and we'll start at a minimum down here. Why there? Phase shift is left 90. Why the minimum? Because our graph is flipped. And 1 point unlocks everything. The period is 180. So in 180 more, we're going to have another min. And another min. And another min. I'm going to pass around the rest of the practice while you guys finish your sketches. I'll give a little team talk and then let you guys practice. Good job today, guys. Starting point, SP. You can write start, or you can do it like a green flag.
These two are the same. Oh, no, you did. So, you have this one. You don't have
Yeah, the period's 180, so you have minimum at 1 point, you'll have another minimum 180. They repeat. Maximum halfway in between. Done what? Yeah, this is the 3U stuff. Yeah, I explained that in detail. Your course, sketching cosine functions is not a requirement. I see how it is. Time the washroom breaks for when we're done. We got a lot of cycles in this one here. Three you people, 3 cosine functions in the books. Anything you guys want to chat about? Okay, you guys did well. That went by fast, but I wasn't expecting to go past 11 still making graphs with you guys. Tomorrow, well, first of all, now you guys just need practice. You need to drill it in a little bit so it becomes second nature. Later on in the week, we want to model real-life phenomenon with sine and cosine functions. So we want to have a good understanding of what they look like, how to graph them. The practice. I should also say tomorrow with all those field trips, we'll do a little extended warm-up and then an assignment tomorrow. I don't want to do anything new with a significant portion of people gone. With the practice, the 3M people just have a note that the third page of that, there's 3 cosine functions. Not expected for you guys to do those. And then number 4, a little challenge for you guys. Can you come up with the equation of those 4 sine functions? I've given you the graph, so all the properties should be visible. So it's a good little exercise. We'll warm up with those kind of questions tomorrow. Okay, you guys did really good today. You guys are doing great. Do you guys know there's like 6.5 weeks left in the semester? That's it, right? We're winding down.
That's good.
Yeah. Time has flown.
Yep.